This video is about our new build process that I created for our SaaS projects, and this is the first time I used tools.build. Tools.build is a library of Clojure which helps you to create your build process, and the philosophy behind it that is that your build process should be code, so Clojure code, like all of the other stuff you are doing. And during this video I will show a few points where this really helped to get rid of some accidental complexity. So first of all, our SaaS products are run as a Docker container, and for this purpose we're using this library here by Google. It's a library for Java which allows you to create a Docker container without any Docker daemon, so you can just invoke it from Clojure and you will be fine. So it's pretty practical if you build, for example, your project inside another CI server, which may be a Docker container itself and so on. Then you don't need this Docker in Docker thing where you need access to the Docker's Unix socket and so on. But there is also one excellent library for using JIP, the Google library from Docker. That's here Pack Alpha, and we also used it before. But my initial motivation to redo our build process was that I planned to add another modification, how Java is invoked here, or the Clojure program, because there was no way to customize this part here. And previously I also did a pull request and adding support for including here multiple layers. So layers is every time you add something to a Docker container, it will create a layer, and we have the need to add multiple folders to the Docker container. And previously there was only supported one, but after the rewrite, regrettably, there's still work in progress, that the support for layers will be re-added there. So that's why I reconsidered how we built our project in general, and I was aware of tools.build, and let's just do a walk through the code. So that's the build process. Just put it here in a subfolder, and as the site here already states, it's just a normal program. So the basics here are from the examples over here. So there's like you build a jar file, but I like to build a so-called Uber jar. So this jar file will include your source code and the compiled stuff from your project, but also all your project's dependencies, so that essentially you can just call your project with Java minus jar, and everything will be there without you having to build the whole class path. So as I said, this was the starting point, and I'm just defining here the class folder, the so-called basis, which is just the metadata about the stuff which you defined via your deps.eden file, and where this Uber jar file should be written. I just used target here, this folder, which you may also already know from Leiningen, just as working directory. So it's sometimes important to clean the previous artifacts of the previous build. So the clean task will just be invoked first to start from an empty target folder. And yeah, this function here is the one which builds the Uber jar, and it can also just be called from the command line. But the better thing is here that you don't have to change the way how you develop your program, so you can develop your build process the same way you develop all your other Clojure programs. So in essence, we can just connect to a REPL and get started. So therefore, I've made some notes here. So first of all, I added this part here to our deps.eden file. So new alias build. Added here the dependencies tools.build, also the library for the Docker container from Google, and also the excellent library from the Babeshka project process, which helps you to invoke shell commands and subprocesses. And yeah, this is a way here how you can start REPL. Sometimes it's also difficult to have the overall concept. And for example, I also had to look up here that you can separate here with the colon multiple aliases to call this. So we essentially adding here the build alias we added to the deps.eden file, and I'm also using here the deps.eden file from Practically, which has here all kind of wonderful tools you can use directly from when you're using deps.eden. So this file needs then to live inside your home folder .clojure deps.eden, and I'm going to invoke this alias here, which just will start the nREPL. So, and when this is started here on this port, I can just connect to the REPL and start with the normal Clojure development flow. And here's, for example, the class here, what it will be like and so on. But I also developed some helper functions, like here just creating a timestamp, which I use for the Docker tag, and can just do your normal Clojure development, REPL driven development thing. And the Uber step here, as I said, that builds the Uber jar file. First of all, it copies all your source folders, so the resources and the source code, into the target directory, which will here in this case be the classes directory. Then it will compile all the Clojure code. We also providing here, which will be the main namespace. And afterwards it builds here the Uber jar and will put it here into the target app jar file. This was here a little bit tricky to find out. So the NS compile stuff allows you to provide a list of namespaces which should be compiled. In the example here, you find the sources dirs. This is of course also possible to use this one, but in our case we have also some old Clojure files which we are not using anymore, and which may have stuff which don't exist anymore, like requiring some namespace which was deleted. And that's why I don't like that everything gets compiled there in this folder. And for this reason, I use this other option to just provide the main namespace, and all transitive required namespaces will then compile as well. Yeah, and as I said, the philosophy of tools.build is that your build process is just an ordinary Clojure program. I also just was able to use here the Google JIP library to build the Docker image, and yeah, it's of course very Java-like. So here, this is, for example, yeah, the starting point I used. There's also parts here where you can look into Pack Alpha, how they are using the JIP library. But essentially, it's telling here, okay, what should be the base Docker image for your build. And we're using another process which builds the base Docker image, which then includes other tools which we are using, like FFmpeg, for example, and many other stuff. But the good thing is with JIP, you can skip to invoke Docker another time just to add a jar file to it. And yeah, we're setting here the working directory, so where the container should be starting, in which folder, and yeah, also the entry point. And here I will also be able to customize how the entry point should look like. And here I created a little helper function here at layers, which adds those layers to the Docker image. So we're adding two other build artifacts we like to have in the Docker image. And yeah, this one is also the function we already seen, so it's just a timestamp I'm using for the Docker image for the tag to make it unique and treat it as immutable artifact. And yeah, the image here, the step that builds the Docker image and uploads it with the help of the Google JIP library. And then here we call the containerizer, and this stuff is just here uploading it to Docker container registry on Google Cloud. We have here to provide the access token, and in the comments here I also using this here, for example, to don't have to upload it over and over again. I just use the local Docker image, and then your feedback loop is a little bit quicker. But besides that, I've created here a little helper function to use here the Babashka process library to call shell functions. And the good thing with your build process being just an ordinary Clojure program is that it enables us also to extract this into a library, or at least shared repository, so that we can use it for all of our two SaaS projects. And that's awesome because you don't have to do everything twice always. So here with the shell command, I just do the stuff which I also done in the previous build process. So building the front end, it's built with Shadow CLJS, but all the single steps are defined here in the package JSON, and Yarn will invoke it. But yeah, the great thing is that when we have here the output is that when you just like to quickly try out something or correct something, you can just call the stuff here. Okay, we have to pass an argument. So, and the shell stuff here inherits the standard in and standard error from your process and standard out, and therefore you will also just see the normal stuff you are used to when you invoke this from the console, even with your color highlighting and such stuff. And yeah, so that's just building the block here. We're using the cool Clojure Clojure project for building the block. And yeah, now just stop this here because my computer is getting a little bit slow. So yeah, and here is for some part we need here, I included it as Git submodule, but this I will also switch this shortly into how it's called. It's subtrees by Git, and that's easier to manage than submodules, but this is not done yet here in this project. The build process just do every step right after another, and here I just prepare the params, so I extracted a little bit the params, so the likelihood is the greater that I can use parts in multiple of our SaaS projects. And for example, I'm fetching here the Google Cloud Access Token just to be allowed to push the image to our private container repository. Adding here a few layers to it, and also defining the source folders and also the target tier and the main folder. That's all the stuff we've seen in the functions above. And yeah, this was it pretty much. And you can just call the complete build process here with Clojure. -t build, that's the build alias, and build here is the function. So you can also invoke, for example, the image step here, and you can even add here parameters which will end up as a map as the first argument. So you could even call separate functions here via this command line stuff. But yeah, as I said, it's super awesome just to be able to use the normal REPL to develop it. So here I can also just invoke it, that you will see that it will also just output the stuff like you used to from, I just aborted it because it will take too long. Like you used to, if you're just invoking the build steps from your bash script or whatever. So I hope this was useful to understand all the connections and tools that you may use to create the build artifact of your project, and especially here the Google container, Docker container library is a great relief, because you don't have to have a Docker daemon available just to build the Docker image. There's also more stuff possible, like do better caching. So for example, it doesn't make sense to add the dependencies over and over again to your Docker container, and all your server instances then have to download huge layers every time you do an update of the image. But it's not really necessary, so that's why I just gone with the Overjar approach. But yeah, there's a lot of optimization possible with this library.